Welcome to java9s.com. In this session, we're going to discuss about Java data types and conversions. Java has different kinds of primitive data types which are used for storing the data like numerics and alphabets. The first kind of data types are integers, like which can be used to store the whole numbers. They are byte, short, int, long. These variable types can be, these primitive data types can be used to store the numbers like 10, minus 15, 30,000. Like these data types does not store the numerics which has decimal places like 10.5, 10.53, etc. And the second cut is about the float and double, which store the decimal places, numbers with decimal places like 25.6, 44.567, and also the negative numbers like minus 23.46. The last set is the char, which is used to represent a single character, and char can also be used to represent the Unicode. And Boolean can only represent either true or false, so it is two. So now let us see how these primitive data types can be declared in the programming. The primitive data type declaration is straightforward and inherited from C, so it's not really tough to understand. It's just straight, like byte A is equal to 20, short B is equal to 22 in C, and long. But please remember, when it comes to representation of float, once you are directly assigning a number to the float, you need to assign a small f or a capital F at the end of the number. So you're explicitly telling that this value should be fit into the float. So, and when it comes to double, it's directly you can represent the 2234.5, or you can append small d or capital D at the end of the number. Whereas char holds a single character which should be represented in single inverted commas, and Boolean, it's either true or false. Now let us discuss about the memory allocation for each and every primitive data type, and what are the range of numbers they can represent. So what are their limitations too? So when you take byte, it has been allocated with 8 bits, so that it can represent around 256 numbers totally. So on the positive side, we have 0 to 127. So 0 is considered to be a positive number in programming languages, so 0 is included on the positive side, so we get only 127 on the positive side. And on the negative side, we have minus 1 to minus 128. So totally 128 on the positive side and 128 on the negative side. Totally it becomes 256 numbers. In the same fashion, short is being given 16 bits, which can represent around 65,536 numbers. And int is more, it's up to 32 bits, so it can represent more number of numbers. And for long, it's 64 bits. So long can be used to represent the milliseconds or astronomical distances, something like that. And if you need to represent the numbers which are more or bigger than this, there are certain classes in Java known as big int, integer, something like that, which can be used. Then coming to float, float has been allocated 32 bits, double has been allocated 64 bits, and char is 16 bits. Please remember that we know ASCII values, like there are 256 characters which needs 8 bits to represent, but here in Java, char has been given 16 bits because it's going to represent 65,536 characters from different languages around the world. So that's the reason why Java has got internationalization support, which can represent languages like Chinese, Sanskrit, Tamil, different languages from around the world. So when it comes to boolean, it's just going to store true or false. So please remember that it's not just one bit, like 1 or 0. Please don't get confused. It all depends on the kind of operating system the JVM is running on. So we say it as an JVM dependent. Don't ever say it's just 1 bit. It's not 1 bit. It is all depending on the JVM and which operating system the JVM is running on. And remember, one should have a very good understanding of what are the limited range of numbers that these primitive data types can store. Very important to understand. I would like to explain this with an example. Ariane 5 is a rocket launching vehicle which has used one of its software package which is used in Ariane 4, which is an earlier version. But Ariane 5 can fly more higher heights than Ariane 4. So because of which there was a kind of conversion between one data type to other data type. So there was a floating point value which has to be assigned to an integer type which can only hold a 16-bit. So eventually, when a bigger type was tried to assign to a lower memory value, the software has failed to handle this conversion, and the rocket has got blasted in seconds. Within few seconds it was launched. So please remember, when you are using a data type, you need to have an idea of what kind of range this data type can be assigned while the software is running. What could be the range? So you should have a clear understanding of the probable values that might come into this data type. And when it comes to default values, please remember that these data types can be declared as an instance variables or local variables. The local variables are those things that are declared inside a method, and instance variables actually represent the properties of a class. So when they are declared as instance variables and they are not assigned, if they are not assigned to any value, then JVM gives them the default values. So for when you say byte B and just leave it without assigning a value, then JVM gives the value as 0 automatically. So byte, short, int, long will be assigned 0. Float and double will be assigned with 0.0, and char will be assigned with /u 0000, which is actually a blank space, which is a Unicode value, and boolean will be assigned with a false. So please remember, it's only the instance variables which will be given the default values. And coming to the type conversion, please remember that it is easy to assign a shorter value to a bigger range data type, like byte can be assigned to short can be assigned to int, and long. This will be done implicitly by the underlying virtual machine. But when it comes to the reverse way, that means when you're trying to assign long to integer and to short and byte, you need to explicitly say to the JVM that you want to force to go ahead with the conversion. With this, there might be some loss of data or incorrect values might come out. So please remember that when you are trying to assign a bigger range of values to the smaller range data types, obviously explicit casting is needed. The JVM or Java will not try to do that implicitly. So for the float to double, it's implicit, and but when it comes to double to float, we need an explicit casting. So whereas boolean cannot be casted, it's a totally different data type. Now I would like to explain this with an example. Here you can see that I am declaring an byte C is equal to 120. 120 is within the range of byte, because on the positive side it can hold up to 127. So when I am assigning this byte to a short, it will directly take it. There's no problem in assigning this to a short data type. When it comes to explicit casting, say I have declared an variable known as a short c is equal to 234, and now I'm trying to assign the same to the byte. I have to go with explicit casting here. You can see that I'm trying to use explicit casting here. So whatever you're trying to store into the end type should be placed here. So there will be a data loss because 234 cannot be represented by byte. So you might be surprised to see that when you print D, there could be a negative value might also get printed. So we in the last of this session we should also know how Java actually represents a positive and negative numbers. When it comes to bytes or positive numbers, it's directly a binary conversion will be done, and it will be stored directly into the variable. Here you can see that byte B is equal to 120, and B is going to store the binary pattern of 120. It's 0 1 1 1 1 and 0 0 0. And when it comes to negative numbers, like when byte C is equal to minus 120 has to be stored, please remember that the 2's complement will be applied, and then the binary representation of that number will be stored. So let us see what is 2's complement. So 2's complement is having two steps. One is first you have to flip all the bytes that have been that are there in the positive representation of that number, and then add 1 to it. So here we have got 120, which here we got the positive number representation in binary format, and I'm adding 1 to it, flipping all the numbers, so ones to zeros, we get this one, and I'm adding 1, we get 1 0 0 0 and 1 0 0 0. So you can see that the most significant bit here is 1. This is where by looking at this binary value, when the MSB is 1, then the JVM comes to a conclusion that the underlying number is a negative representation, so it assigns a negative value. So it converts it to a number and assigns a negative symbol to it. So please remember, if you have 1 at the most significant bit, then it will be interpreted as a negative number. So let us see a small example of the data types here. I'm creating an class known as data type. I'm just giving byte B and not assigning any value to it, whereas I'm creating a short S is equal to say 31,000, and in the public static I'm just creating, I'm just trying to print the value of the byte. Create a short here, short C is equal to 300, and trying to assign it to byte. I'm just giving an explicit casting and assigning it to this, and now I'm trying to print this value. There will be different value that will be coming into A. So I'll just store this. It has no compilation errors. Now I'm just running the program. You can see that here the value of B is assigned as 0. That means a default value is being given. And when it comes to conversion, where short C is equal to 300 is now no more as 300 when it is assigned to byte, it is now as 44. So you can see unexpected results when you ignore the limits of each and every data type. So you need to be very cautious about data conversions that you are going to program in. So this is all about data types.